Hi everyone. We have one more unit circle topic to cover, and that, you may remember from last year, is radians. Radians are another way to measure angles on the circle. You can think of them as an alternative to degrees, and they are based on the circumference of the unit circle. So you may or may not remember this from geometry, but circumference is 2 times pi times radius. Sometimes we also say pi times diameter. Either one would work here. And the radius of the unit circle, we said, is always 1. That's what makes it a unit circle. So if we put a 1 in right here, we find that the circumference is equal to 2 pi. Okay? So what we're going to do on our circle, and I'm doing this on the back side of our original unit circle, just so it's clean. Eventually you will probably want all of this information together on one diagram. So whether that be something you add to your original one, or whether you rewrite the whole thing later, which I actually recommend, it's a good way to study it, you're going to want all of this information combined with all of the coordinates and the degrees and everything else that we've put on the circle already. So I'm going to still call this 0, just like we did when we were talking in degrees. But this time, all the way around the circle, I'm not going to call that 360 degrees. I'm going to call that 2 pi. Okay? And then the rest of this is all just based on your knowledge of fractions. Okay? It can look a little complicated when you put it all together, but really if you just focus on how the fractions work, you should be okay. So if this is 2 pi, then halfway around the circle would be 1 pi. Okay, so those are kind of the basics. That this is 0, this is pi, and this is 2 pi. We have to understand that before we can fill in the rest. The rest of the circle is all just based on fractions of pi. So if you know fractions here, you're all set. It can look a little confusing when you're done with the whole circle, but if you just keep in mind how fractions work and how to count your way around the circle in terms of fractions, you'll be okay. I think the most confusing part of this is that this is not considered to be one whole. All right, this is not a pizza problem from 5th grade. Because this is 0 and this is pi, this top half of the circle is really 1 pi. Okay, and so when we're talking fractions of this part that you see here in green, and then we just continue counting in that same method all the way around the circle. Okay, so I'll show you what I mean. If this is 0 and this is pi, then this halfway point that you see marked up here would be like if we took this pi and we folded it in half, right? And I don't know how well you can see that fold line, but that would be like 1/2 of pi would be at that top line. We call that pi over 2. So if I'm counting in terms of pi over 2, really pi over 2 then would be this much, right? That's pi over 2. If we're counting in terms of pi over 2, here's 1 pi over 2. Here's 2 pi over 2. Now we would normally call that 1 pi, but I'm going to mark it as 2 pi over 2 also. Here's 3 pi over 2. If I keep going, 1, 2, 3 pi over 2. And then finish it out here, and now I'm at 4 pi over 2, which is the same as 2 pi. Now I'm going to go ahead and mark all of these things in, all of these equivalent fractions. It's not so much that we ever call this 4 pi over 2, but it will help you mathematically to understand that these two are the same thing. Okay, if I was talking about this angle, I would just call it 2 pi, but knowing that it's 4 pi over 2 will be helpful. Okay, so what happens when we take this pi over 2 and we cut that in half? And so once again, I'm going to fold this guy in half. Okay, and notice that's really going to line up with that middle dot there. If I unfold this, what just happened is I made 4 sections of pi, right? I just cut this thing into fourths. So the way that translates on the circle, when I'm talking about pi here, this 1/4 would become pi over 4. 2/4, this is the same as 2 pi over 4. 3/4, this is 3 pi over 4. And then 1 pi would be 4 pi over 4. And then let's just keep going. So notice those are all those middle dots. So this next middle dot, if I keep following this pattern, would be 5 pi over 4. 3 pi over 2 is equivalent to 6 pi over 4. This middle dot would be 7 pi over 4. And then 4 pi over 2 would be equivalent to 8 pi over 4. Okay, let's divide it up a different way. So instead of dividing it into fourths, which is what I did a second ago, now I want to take this 1 pi and divide it into thirds. So I'm taking my 1 pi and I'm dividing it into 3 pieces. And let's see how well I can do this. I think that looks about right. Okay, so this right here is pi over 3. Because if you notice, when I unfold this, I've got my pi divided into 3 sections, right? And so this would be 0. This would be 1/3, this would be 2/3, and this would be 3/3. Okay, so in terms of pi, this would be pi over 3, 1 pi over 3. This next one would be 2 pi over 3. And then 1 pi would be the same as 3 pi over 3. And then I'm going to keep following that pattern. Notice on that one we didn't use this middle line here. We went 1, 2, 3. So then I'm going to go 4, 5, 6. So here's 4 pi over 3. 5 pi over 3. And then 8 pi over 4 and 2 pi and 4 pi over 2 is the same as 6 pi over 3. Okay, so what happens when I take thirds and cut them in half? So here I am folded into thirds, right? Now I'm going to take that thing and cut it in half. That's going to give me a 1/6 of pi. That's pi over 6. So let me unfold this guy. Let me number our slices like we've done before. So as I'm traveling around the circle on that one, this would be 1 pi over 6. The 2, notice that falls at pi over 3. That's because this is the same thing as 2 pi over 6. Okay. Pi over 2 would be the same thing as 3 pi over 6. 4, this would be equivalent to 4 pi over 6. 5 would be 5 pi over 6. And 6, this would be equivalent to 6 pi over 6. So if you look at the ones I labeled in purple there, that was pretty much everything except those middle ones, right? I hit everything except the pi over 4s. I went 1, 2, 3, 4, 5, 6. Okay, so I'm going to go 7, 8, 9, 10, 11, 12. So here's 7 pi over 6. This one would be 8 pi over 6. This would be 9 pi over 6. This one's 10 pi over 6. 11 pi over 6. And gosh, I'm running out of room here. This one is 12 pi over 6. Okay, so that's a lot of numbers on that circle. What I really want you to focus on is kind of the first one that I wrote down in each spot. So even though there's several of them that I labeled with multiple fractions, we really want to just focus on the first one that was written down. 0. This one would be pi over 6, pi over 4, pi over 3. So those highlighted ones are the ones that really matter. Those are the ones that we'll actually refer to the angles with. But again, and I missed one here. Again, like I said before, it's also helpful to be able to think of pi as 2 pi over 2 or 4 pi over 4. Because as you're counting around the circle, when you land on that spot, you know what it's equivalent to. Okay, so you can go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. There are a million different tricks and patterns and ways that people use to memorize this thing. I really try to focus my teaching not so much on memorization, but understanding where these fractions come from. That's why I spent all this time with all these folded pieces of paper. Okay, but if you would like to do a little bit of research, if you'd like to go to YouTube and see if you can find some tricks for memorization, please feel free to do so. Okay, but you will want to know what these angles are called, and then you'll also want to know the coordinates that go with each one, which is the focus of a previous video. Okay, that's it for radians. Thanks a lot for your time.